So I've got some interesting stuff to share with you guys since I've got these numbers now finally looking like they're in harmony. Not these numbers that you're looking at right here. This is actually all of the numbers using standard pi. So you can see that the circles right here increment by 7, these circles increment by 11, these circles increment by 14. So as you can see these numbers up here, we got pi. You can see it comes from Microsoft Excel because it uses the function pi as well as the square root of 2. The only thing where we actually see integers here or anything with a short number of numbers after the decimal place is where we actually have the number of the circle, or if we're talking about the perimeter, because you're just multiplying the diameter times 4. That's the only place that you can see that kind of thing here. So now let's take a look at what it looks like now with the adjusted pi. And believe it or not, it turns out that the square root of 2 is also functioning the same way as pi is. So let's take a look at that. So this is what the numbers look like when you plug in the two versions of pi. So for anything that has factors of 7, then we use the pi version, which is 3.142857 repeated. If we have circles with factors 11, we use the number pi 3.14181818, so on and so on. Interestingly, I found that the square root of 2 functions the same way. As you notice, we don't see lots of decimal places, or lots of numbers after the decimal place where we have the square root of 2. And the series of numbers works the same as well, because if we see on the 7s and on the 14s, we have the 142,857. So we have 1.4142,857 repeated. And you can see this is what we get as opposed to this. And if you notice, the numbers are going to look very familiar as well. So additionally, the degrees are also majorly cleaned up by doing this. And if we take a look at the numbers where we're actually getting pi, you can see pi is extremely clean, and it uses the numbers that we're familiar with, like 518.4 or 51.84 or 5.184. It really doesn't matter where the decimal place is, because it's these numbers that are used over and over again, which are all factors of this 186,624. We see these numbers here over and over again inside that list when we square all those circles. So this is what it looks like. And just to kind of show you, what I did was I went ahead and just highlighted a few rows so that you can kind of see what it looks like. I mean, there's tons of things in here, and I mean, it's just repeatingly the same numbers over and over and over again, with the decimal place changing or anagrams of each other or what have you. It's really interesting to see it all happen. The only thing I've noticed is that where the degree is on the 7 and on the 14, you still have these repeated numbers. For the degree, for the 1 degree on the 11 circles, you can see you don't have the same kind of thing going on, which is really interesting. So, I mean, right off the bat, I can point out to you, this is the number of miles from the Earth to the Moon. This is the number of miles in millions of miles from the Earth to the Sun. The 186,624 is the diameter of the whole circle between that the Sun is on. The 864 represents the Sun's diameter, 864,000 miles, and so on and so on. 2016 is just an anagram of 2160, which is an anagram of 216, and so on and so on. So let's just take a look at a couple of rows that we can get here, and we'll just select the ones that are yellow. And there's tons of them like this. I just happened to select these real quick for you guys to see. So if you take a look, you can see the 103.68, 69.12, 34.65, 207.36, 5184, 1866. You can see it's repeated too, right? So here we have 207.36, here we have 207.3.6. The 2592 shows up all the time because it's the same as the 25920. 46656, 31104. Every one of these numbers you'll find right here. And then of course this can be multiplied times 2 as well, but it's the factors that are contained within this set of numbers over and over again. I just pointed out to you many of these numbers right here. It's full of them. And there's a couple of ones that I saw that were significant. I think one of them, of course, was this one here, because this one here, you're seeing the 594, which actually squares the 756 circle. The pi of that is 186624, and each 1 degree on that circle, each degree is 5.184. And then, of course, here's the 756 circle with 2376. 106.9.2 is its diagonal. So now you can see what this looks like. The numbers actually have some kind of a harmony to them if you know what you're plugging in and you know how these things work together. I think this is really, really important, and I think it's one of the necessary things that we needed in order to solve this riddle or this puzzle. The next thing I wanted to show you is, because of the harmony in the numbers here, it's easier to see the relationship between the pyramids. So now what I did was I plugged in the side length. These were 7 circles, right? So I plugged in the side length of 340.2, and I did that for a particular reason. If you look at these numbers across here, you'll notice that the 340.2, if you multiply it times pi, you get the diagonal of the Great Pyramid, which is 1069.2. If you multiply this times the square root of 2, which means that you take that square and you turn it 45 degrees to where the corners are pointing up and down, then you get 481.14. And with the numbers now working in harmony with the system showing these things the way that they should be seen, I'm pretty sure that the height of the pyramid is supposed to represent something around 481.14. If we take a look at the ratio between the perimeter of this number here, which is 1360.8, and we divide that by 1069.2, and then we actually get the square root of phi. So if I take this number here and I divide that by 1069.2, you can see I get the square root of phi. So this would be basically the same as 14 over 11, something like that. So here we have these 11 circles, right? So this 11 circle here are 240.625. If we multiply it times pi, we get 756. And if we take it and turn it 45 degrees, we get 340.2. And this is where I wanted to kind of show you the geometry and show you how it works. Now the pyramid complex is there to teach us. I've figured this out. I'm very sure of this, and the formula or the blueprint where we get the instructions for doing all of this stuff is actually from Khafre. Khafre was designed because it uses numbers that present ratios in raw form. It is the one of the system. So that's the reason why the diagonal of Khafre is 1000, and it's not anything else. And actually the side length is 707, because they're trying to teach us about this whole geometry thing and the way that it builds and folds and expands. So if we take a look here, this is what it looks like. And there's a really quick way to do it, which you do this. But if you miss, if once you get through all this and you can see it quickly, and I tried to keep it simple for you, then you miss a lot if you don't go and check out all of the various ratios that Coffray is showing you. So just to show you real quick, you start out with 107, which is the side length of the pyramid of Coffray, right? And if you take that and you turn it on its diagonal, you get 1,000. So what I decided to do was just to kind of show you, I started from this larger number, and if you notice, it is 3142857, okay, which is basically the number representing pi. This number 2222.2222 in a way is kind of like 22, because Coffray is 707, so it's kind of like 22 over 7. Because this number here, or the side length that you see right here, is actually Coffray times pi, and that's the reason you see Coffray right here 3 times with the 0.14, because it is actually multiplied. It's actually 22 over 7, which is what we get as the side length here. But back to the original thing here, we have 3142.857, and then we have 2222. And the way this geometry folds, of course, is you can just take your squares and turn them, right? And then you take your circle and you place it inside the next square. So the way you can do that is you have kind of 2 scenarios here. So if you want to get this particular one here, and you want to get multiplied times 4, will give you the side length. So the perimeter of this guy right here will give you the side length of this guy, and that's doing the square root of 2. You go 1, 2, 3, 4, 5 times will give you that from this number up here. From this number, it's actually 4. So what this tells you is that, of course, every time that you do the square root of 2, if you do it twice, you divide the number in 2, right? So if I want to get to 5 from 10, I do it once, and then I get a number, and then I do it one more time, and I get 5. Okay, so it works the same way here, except we're getting 4 of them, so we have to do it twice as many times. So the interesting thing between these 2 scenarios here, and why this one's pi and why this one is the perimeter, is because what it wants us to do, the riddle or the puzzle here, is when you get to a certain point, when we get to 1111 right here. So for example, let's take a look at the numbers real quick. We have 2222, which comes from being the diagonal here of 3142, right? So then we have to stretch this one out, and this one is the diagonal or the length of 2222. But then when we turn that square this way, then we get the number for pi over 2, because it is 1571.348. So it's the number for pi over 2. So then we do that again, and we go from there, from pi over 2 to 1111. So if we do this again, we miss the 707, 107. So how do we get there, right? That's the puzzle. And we get there by taking this number here and multiplying it times, or taking 90% of it. And that brings us down 1 notch here. And the reason I've got these degree markers here is because if you take a set of circles and squares, so say you take this circle here and this square, and I multiply that, and I basically take off 10%, then what you've actually really done is you've squared the circle. And that is the riddle here, because once you've squared the circle, then you're down to 707, 107. So what's interesting is, so that gives you Coffray, and Coffray, the pi times pi, gives you this 2222 number, which is 22 over 7, basically. Now the 5555 is basically when you take this, and if you notice, it's the 785, 674, which actually turns out to be the number for pi over 4 when you're dealing with 1,000. Okay, so if we are dealing with the side length of Coffray, the diagonal is 1,000, and so if we take the square root of 2 of that, then we get the 785 number, and then of course we take the square root of 2 of that and we get this 555. This 555 squares Coffray, as you can see right here. And when it squares Coffray, then you get the perimeter equaling the same number. So if we take a look, this is our formula here, so if we take a look down here at the Great Pyramid, it uses the same formula. So this is 1069.20, which is the diagonal of the Great Pyramid, and this is the 756, which is the side length. So if we step through and go all the way down to 1, 2, 3, 4, we get down to 189 feet, and that is 756 divided by 4, and that's why you see this right here. So the perimeter of this square here is equal to the side length of the Great Pyramid. So if we do the other scenario here, then we get down to this point, and instead of doing it another time, in order to get to the one that we need for pi, we take the 378 square and circle, which is right above it, and we take both of those and knock off 10% of them, and then what we get is we get this value here, which is 340.2. Well, 340.2 times pi is 1069.2, which is the diagonal of the Great Pyramid. If you take that 340.2 and you rotate it to where the corner is up and down, which is what you see here, then you get the 481.14. And then if you take the square root of 2 of that, of this particular one here, which is the 340.2, well, that actually gives you the value if you wanted to multiply it times pi in order to get 756. So as you can see, as you move down this thing, 340.2 times pi is equal to the Great Pyramid is diagonal, which is 1069.2, whereas the 240.625 multiplied times pi, which is this number, which is inside of that, is equal to the 756 number. The 378, which we saw right here, times 2 is equal to 756. And then over here you can kind of see the way it looks, because the 481.14 is basically the 340.2 turned on its side here, these blue squares that you see. And this circle, which is the 481.14, the 378 squares that circle, as you can see right here. And that's the reason why if we take 481, which I kind of showed you with the rhombus a while back, but if we take 481 and divide it by 378, then we get our number. It looks like this one's dealing with sevenths, but we get our same version of the square root of phi. And so this is the way the system works, and it doesn't matter what size pyramids that you're using, and this is how we know what they're showing us. They're actually showing us a movement, so it's a riddle. So the middle pyramid, Coffray, is the one that has the blueprint. It's the one that presents the ratios. The little pyramid is the mystery, because we don't know how it gets to be related to the Great Pyramid, but it's related to the Great Pyramid by using the formulas found inside Khafre, which gets you to the relationship of the Great Pyramid, as well as taking a look at the numbers that are in harmony. Now, something to keep in mind about the Khafre Pyramid is as you're doing all of this, there's a lot of stuff that you can miss if you don't take a look at what's in front of you. So you can decrease these circles by 10% as many times as you want, and you're always going to square the circle every time you do it. But here are some interesting numbers that come out when you do it this way. So you get the 2222 number, right? That's Khafre times pi. This is 2,000. This is 1,800 feet. When you get to this blue square right here, this is the 1,800. If we turn that into a square, from a diagonal into a square, then we actually get 1272.792, so we get the square root of 5, which is what this is right here. This square root of 3 number that you see right here, if you see this square has been rotated, right? It's rotating around this circle right here, and this circle that is rotating around is the 1414-214. And so if we take this 2222 number, which is right here, and if you remember, when we turn it this way, we get 1571.348, which is pi over 2. If we take that number and we decrease it by 10%, we get the square root of 2 ratio. And then if we take the square root of 2 ratio, which is this right here, well, basically it is where this yellow square is, which I'm going to rotate for you here real quick. So you see it's flat right now, so the 1414 is sitting right on top of it. But if you rotate that square, okay, so if you notice the numbers up here say 1414, 214, if you rotate that square 15 degrees, you get 1732.05. So let's just prove that real quick. So the square root of 3, 1.73205, so we get the same number. And of course all of this is just simply the ratios multiplied by 1,000 in order to make them pyramids. And then of course if you keep going down and then you finally get to from the 1111 number, which is right there, and then you decrease that by 10%, then you get 1,000, and then you decrease that by 10%, and you get 900. 900 rotated up, you get the square root of 5. If you take 900 and decrease it by 10%, you get pi over 4 value right here with the 785.674, and then you get basically the square root of 2, which is kind of like the reciprocal of that down here. All of the numbers down here inside of Khafre are reciprocals of the numbers that you see on the outside. So for example, you'd have pi over 2, which would be the number would look something like this. So if we had pi over 2, 0.571, 42857, and if we took the reciprocal of that, you'd see a circle down there that looked like 636,363 would be contained somewhere in here by doing the same folding of the geometry. And so this is what shows, this is what they're teaching us here in this complex. And so they're showing us also that this happens at all different levels, right? So, and if we can take a look at the numbers, we can see that as well, because the numbers simply just change decimal places as they go up and down. But we're still seeing the same type of progression in geometry. So anyways, there's still more to learn, because the whole complex is actually being designed in order to show something as far as a diagram goes, and it has something to do with this type of geometry, but laid out to where all 3 pyramids are contained inside of it that we can see. And so I've still been working on that right now, and I've seen some variations that look promising, but I'm still not satisfied. But as soon as I get to that point, I'll share it with you guys. But I just wanted to show you kind of what is going on here. There's definitely cracking the code, and I wanted to share it with you guys and show you what's going on so that you can see it yourself firsthand and see these numbers in harmony. And the next things I'm going to be working on would be the actual degrees and precession, these types of things. And as I come up with some things, I will share them with you guys. So you guys take care, have a good night, and I'll talk to you soon.